In this video, I want to talk about solving radical equations that are written in function notation, like this example here on the right. It says if f of x equals the square root of x plus 2 plus the square root of 3x plus 4, find all values such that f of x equals 2. And remember, f of x is the same thing as y, and we want to know when it will equal 2. So we're going to replace f of x with 2. So 2 equals, right, just substituting that in for f of x, and we have everything else stays the same. So now we have a radical equation, and we want to solve for x. I have two radicals here, so I need to isolate one of them. Again, doesn't matter which one. So I'm going to go ahead and subtract square root of x plus 2 from both sides. That leaves me with 2 minus the square root of x plus 2 equaling the square root of 3x plus 4. I've isolated one of the radicals. Now I need to square both sides of the equation. Remember, this left-hand side, it's 2 minus that square root. I need to box or FOIL. This is two terms being squared. So box or FOIL that out. And for the sake of time, I'm going to leave that foiling and boxing to you. But what you should get is, so the shortcut way of multiplying that is 2 times 2 is 4. Multiply the two terms together. 2 times the negative square root of x plus 2, and then square it, or sorry, double it, would be negative 4 square root of x plus 2, right? So 2 times negative square root is negative 2, double it, now I've got 4. And then lastly, square the last term. So negative square root of x plus 2 times the negative square root of x plus 2. The negatives become positive, and the square root of something squared leaves us with x plus 2. On the right-hand side, we have the square root of something squared, leaves us with 3x plus 4. Now, I have gotten rid of one of the radicals. I need to get rid of the other radical. So I'm going to go ahead and gather up some like terms here. I'm going to subtract 2 from both sides and subtract 4 from both sides. That's 0, that's 0. And subtract an x from both sides. That leaves me with negative 4 square root x plus 2 equaling 3x minus x is 2x, and plus 4 minus 4, that's 0. So I just have this minus 2 here at the end. And then from there, again, it's your choice if you want to divide by 4 to isolate that radical totally, but you don't have to because that is multiplication. And squaring is just a shorthand for multiplication as well. So I'm going to consider that isolated and square both sides of my equation. Negative 4 times negative 4 gives me 16 times square root of x plus 2 squared is just x plus 2. On the right-hand side, I'll have 2x times 2x is 4x squared. Negative 2 times 2x is negative 4. Double it, get negative 8x. And negative 2 times negative 2 is a positive 4. Going to go ahead and distribute. 16 times x is 16x. 16 times 2 is a positive 32. Now, we have gotten rid of all the radicals. We need to stop and evaluate what's our next approach for solving. I see an x squared. This is not linear. That means I need to get everything on one side, set it equal to 0, and try to factor. So I will subtract 16x from both sides and subtract 32. So minus 16x minus 32. 0, 0. The left-hand side is 0, equaling 4x squared. Negative 8 plus a negative 16 is negative 24x. And negative 32 plus 4 is a negative 28. First step of any factoring problem, look for GCF. Make your life easier if you can. I see these all have a common factor of 4. I will divide that out. Negative 24 divided by 4 is negative 6. Negative 28 divided by 4 is negative 7. Now I need factors of negative 7 that will add to negative 6. That's going to be 7 and 1. So negative 7, 7 and 1. One of them needs to be negative to multiply to a negative. And I also want it to add to a negative 6. So I'm going to put the negative with the 7. This leading term is 1, or the coefficient is 1. So I can go right into my parentheses. I'll still have that 4. I'll have two sets. X times x will give us the x squared, and our factors were negative 7 and a positive 1. That means that x could be, we set each factor equal to 0, x could be positive 7, would make that first parenthesis 0, and x could be negative 1. That will make the second parenthesis 0. Now let's check them. We have to make sure they work. Plug it in. Let's start with 7. So 7 plus 2 is 9. Square root of 9 is 3. So this first radical gives us 3. The second radical, I'm still plugging in 7. 3 times 7 is 21. And 21 plus 4 is 25. Square root of 25 is 5. So we said this first one was 3 plus 5. Will that give us f of x equals 2? Nope. That's actually not a solution here. Let me go ahead and write that out so you can really see it. I'm going to check it up here. So we were letting f of x equals 2. I want to know if 2 equals the square root replacing x with 7. 3 times 7 plus 4. 7 plus 2 is 9. Square root of 9 is 3. 3 times 7 is 21. 21 plus 4 is 25. Square root of 25 is 5. 2 does not equal 8. That's not a solution. It's extraneous. Try the next one, negative 1. Plugging in negative 1 for x plus 2 would give us 1. Square root of 1 is 1. Second set, 3 times negative 1 would be negative 3. Plus 4 gives us positive 1. Square root of positive 1 is 1. So we had 1 plus 1. We do get 2. So there's our x equals negative 1. It's our only solution.